Welcome to another video in our series Commissioning a variTRON System. My name is Manfred Schleicher. I work at JUMO as a technical trainer, and in this video I will show you the most important steps for expanding a variTRON configuration with PLC functionality using CODESYS. I will show you helpful options in CODESYS and how you can use it to address hardware. In the middle of the video I will create a logical function in the programming languages ST-code and CFC. I will show you how to generate alarms from the PLC and how the alarms are handled in the visualization. With regard to visualization, I will show you at the very end how to name a controller channel, change physical units and set the decimal places. Let's get started. Please imagine that I have here the project from the last webinar. I have made all settings in the configuration program and I would normally transfer this to the control system first. I'll just indicate the transfer for you. From the configuration program, I'll go straight into CODESYS with you, so I'll switch to PLC application here. I make sure that the current version of CODESYS is set. For system version 8, this is version 3.5, Service Pack 19, Patch 2. And now I start the selected CODESYS version. I open the main program in CODESYS. The main program is called cyclically and is written in ST-code. I want to control a digital output from the program. The hardware has been transferred to the CODESYS and I can see it here in the order in which the input and output modules are arranged next to the CPU. You have to map the hardware that you want to use in CODESYS. I'll show you how to do this using digital output 3 of the regulator module as an example. I open the I/O mapping for the controller module. Here you go to digital output 3 and give it a name. This defines a network variable that is assigned to digital output 3 at the factory. Here I show you this in the configuration program. In the configuration program I switch to the configuration and here I am in the controller module, namely in the digital outputs. And here you can see the network variable that I used as the control signal for digital output 3. And let's make the variable available by mapping it in the CODESYS. In the System Bus I/O mapping window, I give the variable a name and this creates a global variable that I can use to access the hardware. I now switch to the main program and from here I want to operate the hardware. While writing the variable name, all variables that start in the same way are already listed here. Select the corresponding variable from the list. If the list is not displayed, activate the following option. With a few exceptions, you end all lines in the structured text with a semicolon. Before you transfer the program to the system, generate the program code and check it for errors. Here you can see that the program is without errors. You can load the program with the configuration into variTRON 500 as follows. You close CODESYS. In the configuration program, you then apply the change to your CODESYS session. To do this, go to PLC application and transfer the change to the CODESYS application to your configuration file. Finally, transfer your CODESYS application together with the configuration to the system. I am only hinting at this here. You can also transfer the CODESYS application independently of the configuration. I will now show you how to do this. Here the main program is open again, which I have only extended by one program line. To connect to the CPU, I go to Online and here to log in. When I want to connect to the CPU from my project for the first time, the window for the CPU opens. Here I have to specify the CPU to which the CODESYS application is to be transferred. I can try to display the CPU via a scan and then select it. Alternatively, I can enter the IP address of my CPU here. I can read the address out via the variTRON 500 display. After pressing return, I make this connection the active connection and I will use it for my project from now on. I log into the CPU, transfer the configuration, and start the program. Next I will control the variable in the main program and thus the digital output of the regulator. In the main program I can see that the status of the variable is false. I can prepare this here by double-clicking on True. I force the status to True by going into Force mode. The variable is true, and if you were sitting next to me here, you would recognize that the controller output is also activated. By selecting the status, I can prepare it again and again, such as false here now, and can then also accept it here. Alternatively, I can also use the F7 key to accept it. And now I finish forcing. Next I will make the actual value of the regulator available in CODESYS, respectively in the PLC. The actual value is also made available in the visualization. We can see it here and will now bring it into CODESYS. For the modification of the program, it is necessary to log out of the CPU. Next I have to map the actual value of the regulator. It is then available to me as a global variable. In the regulator, I move to I/O mapping. This is the actual value of controller channel 1. You can see the input and output folders here. This should always be viewed from the PLC perspective. Input is everything that is written to the PLC. Output is what is written from the PLC to the I/O modules. The actual value is written to the PLC, which is why I find it here under Input. Under Actual Value 1, you will not only find the actual value of regulator 1, but also, for example, the unit or error status. However, we are only concerned with the actual measured value and you map it at this point. I start writing the name. When mapping, I always start with G because I am creating a global variable here. Then there is always an underline. Because this is a real variable, then comes the R, and then I simply write PVC1 as the name. My aim now is to display this actual value in the main program. I switch to the main program. Here I call up the variable. After I have written the name here, I end it with a semicolon. I have just shown you that I always generate the program code first after modifying the program and check it for errors. However, I now initiate the transfer directly here. Before the transfer, the program code is generated first. If there are any errors here, they will be displayed to me. The program code is generated and transferred to the CPU. I start the program and the actual value is available to me. I want the actual value to change here too, so I enter a higher set point in the visualization. The regulator tries to adjust the actual value to 155 degrees and I can now also see the changed actual value here in the main program. For a better overview of our troubleshooting, you often need to know in which program parts a variable is used. The cross-reference list is a great help here, and this is how you display it. For example, if you want to know where the variable is used for the actual value, click on it, and in the cross-reference list you can jump to all the places in which the variable is used. Now I would like to show you how to implement an assignment and a logical operation in the main program. Then I will create an additional program in CFC and call it from the main program. I start by mapping the first 4 digital inputs of the regulator module, which I then use for the logical operation. Again, I start with G because these are global variables and you can see the names I use here. And now I still need Boolean output variables, and so I map digital output 4 and output 5 of the regulator module here. With a small extension of the main program, I now assign digital input 1 to digital output 4. In the structure text I always start with a target, in this case digital output 4. For the assignment, I now write the colon and the equal sign and then the digital input 1 accordingly and end the whole thing with a semicolon. If I want to AND the digital input 1 and the digital input 2 and OR this result with the digital input 3, I do it like this. I use build to check the program for errors. There are no errors and I do not transfer the program. Now I will create this small program extension with a program in CFC and call this program from the main program. And this is how it works. I make a comment from my program line and then it is no longer processed by the program. I achieve this by writing 2 slashes at the beginning of the program line. I create a new program organization unit for the additional program. I go to Application, right-click and select Add Object. A POU stands for Program Organization Unit. I give it a name. This is a program, and I want to create the program in CFC. The editor opens and I can see where the program is stored in the structure. I drag 2 boxes from the toolbox. One box is for my AND, and the other for the OR. Accordingly, I need 3 inputs here. And I draw the necessary connections. Then I also need an output, which I also have to connect. I specify the variables for the digital input and the variable for the digital output accordingly. The program is created and I just have to call it from the main program. I do this simply by entering the program name, followed by open bracket, close bracket, semicolon. I generate the program code to check it. The program is error-free. Next, I'll show you how to generate alarms from CODESYS. I'll switch to the visualization and call up the alarm list for you. In the alarm list, you will see alarms that are active or were active but have not yet been acknowledged. You can also acknowledge alarms from this list. And then there is the event list. With regard to alarms, the event list also logs when an alarm was activated or deactivated or when it was acknowledged. If you want to use an alarm, define an alarm text at the beginning. You do this in the configuration program. I am here in the configuration area and under PT configuration, texts, alarm message. And here you can assign a text for the first alarm. We will activate the first alarm directly from the CODESYS whenever the actual value exceeds a certain limit value. The alarm text temp to high should then be displayed. To make the change effective in the system, I have to transfer the configuration again. And now I am expanding my PLC project. I can control the alarm status by a variable. The variable is located in the global variable list GVL OEM alarm. The alarms are organized here in an array called AX set alarm, and in square brackets I enter the number of the alarm, which is 1. This will be an assignment here, so I continue with a colon and equal sign. I now write actual value greater than 180 on the right hand side, and if this condition is met, the alarm is activated accordingly. I generate the program code. This is error-free, and I transfer my program to variTRON 500. By entering a set point of 190 in the visualization, I force an actual value greater than 180 degrees. The actual value has exceeded 180 degrees and the alarm is already active. The alarm is also displayed in the alarm list. And the status is logged in the event list. So I can see in the event list when the alarm became active. By setting a target value of 170 degrees Celsius, I ensure that the actual value is below 180 degrees. I can see the conditions at any time in the CODESYS. I can see here that the alarm is no longer active. I acknowledge the alarm in the alarm list. In the event list, I can see when the alarm was activated, when it was deactivated, and when it was acknowledged. Next, I'll show you how to change texts in the visualization and how to influence the displayed units. I'll start with a text for the controller channels. Here I want to display the text Zone 1 for the first channel. You do this in the configuration program. You go via the configuration, via the controller, to the corresponding channel, and here you change the name to the language you are using. And set the decimal places here. Here for the set point and here for the output level. And this is how you bring the unit degree Celsius into the regulator screen. I have to transfer the changes to the system right now. However, I have made several changes in the CODESYS application that I have not transferred to the configuration file, and I will now transfer these to the file again, but without closing CODESYS. And this is how it works. I switch to the CODESYS. In the CODESYS, I transfer the current status of the application by pressing this button. I still have to apply the changes in the configuration program. And so I transfer the current status of the CODESYS application and my configuration to the system. And I call up the visualization. Here I can see the modified channel name. The set point and output level are displayed without decimal places, and the unit degree Celsius is displayed here. Here you have a home button, and in the configuration program you can define which screen you want to go to after pressing it. For example, if you want to go to process screen 1 by pressing the home button, you do this. In SmartWare program, I am here in the configuration, and you can see where I have to go to make the setting. Here I select process screen. As the count starts with 0, enter 0 for the process screen 1. Now I'll show you how to name screens. I'm in the regulator screen, and this has the default name controller 1. I'll show you how to modify it right now. Or if you go to the process screens, they also have names. By default, the first one has the name process image 1. So you can modify these names, and you do this in the CODESYS. A text list with the names is available in the CODESYS. Here you can see that you can define the names in different languages. For example, you can assign different names for the process screens, or you can name your controller screens differently. What may also be interesting is that if you want to reduce the number of process screens displayed, you can go to this global variable list. 12 process screens are displayed by default. However, you can also set the number smaller, in which case only one process screen is displayed, for example. Finally, I will show how to end your session. You close the CODESYS. In SmartWare Setup variTRON, go to PLC Application. And here you apply the changes from the CODESYS session to your file. Now transfer the configuration to the system. Save the file and close the application.